In this video, we will draw on your understanding of functions as processes that have input values and output values in order to explore what it might look like for exponential functions to have an inverse process. First, let's look at the equations in question 1 of Module 4, Investigation 8. Consider part A, II. Use your reasoning to make a guess at what the value of x would need to be so that 3 raised to the x power would equal 10. So what could x be? Could it be 0? What about 1 or 2? By putting these values in for x and thinking about what the left side of the equation would equal, you can reason about whether or not x must be larger or smaller than 0, or larger and smaller, or smaller than 1, or larger or smaller than 2. In this way, answer all parts of question 1, and then make sure that in part B you write out a description of how you reasoned in order to get the answers you ended up with in part A. We have studied exponential functions such as g of x equals 3 raised to the x power. In these situations, the input to the function has been the value of the exponent, and the output has been the value of 3 raised to that exponent value. For example, if the input to g is 2, then the output is 3 raised to the power of 2, or 9. In Module 4, Investigation 8, we want to reverse this process. What if we consider the output to the function g and then work backwards to determine the value of the input that goes with it? When thinking like this, some questions are easier to think with than others. For example, if the output of g is 81, what input value to g would output an 81? With some thought, we can determine that because 3 raised to the power of 4 gives 81, then the answer is 4. But what if we wanted the specific input value of x into g that would output a 15? That would require us to reverse the process of exponentiation, and that process proves to be more complicated than we might at first think. In fact, this reverse process takes on a whole new class of types of functions called logarithms. The logarithm function takes the output of an exponential function as its input, and then it will output the input value that would produce the exponential function's output. Now that's a mouthful. Let's consider our example to help us keep it straight. We know that 81 equals g of 4 equals 3 to the power 4. Well, if we input the value 81 into the logarithm base 3 function, then that function will output 4. By the way, we usually just say log base 3 when referring to this function, the function that reverses the process of raising the base 3 to the power x. It takes some time getting comfortable using this notation to express these ideas. So let's work with this same problem again, a little bit more formally. We can say that if 3 to the x power equals 81, then log base 3 of 81 equals x. Because we know that 3 to the 4th power is 81, we can reason that x equals 4. So log base 3 of 81 equals 4 because 3 to the power 4 equals 81. More generally, we can convert between exponential and logarithmic forms of an equation in the following way. If b raised to the y power equals x, then we can say log base b of x equals y. Note that for both of these equations to make mathematical sense and to be interesting mathematically, that b and x must be positive non-zero numbers, and that b shouldn't equal 1. With this restriction in place, note that x, b, and y could take on many forms. They could be in fraction form, or they could be an algebraic expression like 3x plus 1, for example. So using this, let's say if log base 3x plus 1 of 12 sevenths equals y, then we can rewrite that equation as 3x plus 1 raised to the power y equals 12/7. Question 2 gives you an opportunity to practice converting an equation from exponential form into logarithmic form. Question 3 continues to give you an opportunity to convert between exponential form and logarithmic form with more challenging problems. Note that before you can convert to logarithmic form, the equation you are working with must be in the form b raised to the y power equals x. For example, we can see that in part D that the equation is not in that form. It is in the form x equals 3 times b raised to some y power. However, you can use algebraic thinking to rewrite the equation so that it is in the proper form, and then you can convert to logarithmic notation. Submit your answers to all parts of questions 1 through 3 in Module 4, Investigation 8, using your instructor's preferred method by the time and date that your instructor has identified.